got and the discussion got round to aviation, and it got round in the end. We got to talk about PAPI, and the guy said, "Oh yes," he said,
"Review of 2023. Looking forward to 24. This is our 37th webinar, and it's actually this is our third Christmas special. So we've been what started off as a COVID filling exercise has turned into something rather more, which is and I certainly, for one, it's a lot of work, a lot of hard work goes into these, and I want to thank everyone for their contributions. But it's actually very useful to and very stimulating to put together these presentations, because it gives you, it takes you down all kinds of avenues, because we explore different things. And we've got a very new avenue which I'll share with you at the end, where we're looking at a new topic with Seward Ford will be leading that webinar. So kicking off now for today, the panel is Tony, eminent world-renowned inventor of the PAPI, and a wonderful expert in terms of all aspects of airfield lighting, has been very much involved in the formulation of all of the standards that we know and work by complying with today. So I thank you thank you personally for the support you give to me in terms of your knowledge and understanding, and it's invaluable, and I really appreciate it. In fact, Tony was very much set in place the building blocks for the creation of the MARM system in the first place, because it was through an investigation and a research project which Tony was part of that MARMS was actually invented in the first place. Seward has joined us from I don't know if you're in upstate New York, downstate New York, but somewhere around that area. Connecticut. Had a career in Kraus Heinz Company, where he developed his knowledge and understanding of airfield lighting, and subsequently as AAA airfield lighting trainer, and now as an independent consultant, and very knowledgeable in all aspects again of airfield lighting, but particularly from an FAA perspective. Carl Johnson has joined us from Avcon, where he's had over 50 years experience in design, construction, and maintenance of airfield lighting electrical systems. Fabulous speaker and presenter at IES, if any of you have had the benefit of going to that, but also now working with Seward in terms of the AAA airfield lighting training. And in fact, I believe it's fair to say you're leading that now. Keith, known to you all as as probably the most world-renowned airfield lighting trainer, formerly customer services head at ADB, and the most knowledgeable airfield lighting person, still active, providing training, consulting services, and helping the aviation industry, as you'll see on his tagline on his on LinkedIn. His role is, and he very much fulfills, supporting everyone in the airfield lighting world, making airports more safe, more compliant, and more efficient. So, and a great friend and supporter. So thank you, Keith, for joining us. So without any further ado, I'd like to kick off with today's webinar. We're going to recap some of the key issues we've been talking about in 23. We've got a prize quiz, and then we'll talk about what we're going to be as we go into 2024. Just to warn you, for the prize quiz, it's an interactive quiz, dynamic software that you will need a second device to hand. So if you're looking at this on a PC, or if you've got a separate smartphone, if you could have that, I will be giving you a PIN code to put in that separate device, and then you will answer your questions on there, and you will see on this Zoom call, you will see the results as they occur live. There's a leaderboard. There's 10 I hope you find interesting questions, and then finally, if any of you have any questions, if we have any time left, if you've got any questions, we'll try and fit in a short Q&A session at the end. So what did we talk about last year? Well, Tony spent the first two webinars of the year describing the origins of the standards of visual aids, looking at all aspects of visual aids, and explaining, putting them in the context of why they were developed, what the visual aid is for, and how it is used today. Keith looked at airfield lighting maintenance best practices from the building blocks up, and then we've got some case studies that we probably won't be able to do justice to today, but I've included in the presentation just in case. Then we'll be looking at AGL service support, which is critical to the whole business of airfield lighting maintenance, and that's a topic close to Keith's heart that he presented on to us earlier this year. Tony then gave us an insight into his view of 21st century technology in relation to visual aids and how we could harness it better to improve things going forward. So it's very much Tony's vision for the future. And then we looked at the subject of, are we giving airfield lighting specialists enough support to do their job? Do they have the resources, the tools, the training, and the equipment? How do we maintain safe and compliant visual aids in a very tough and dynamic environment, which is the runways and taxiways of our airports? So, with that in mind, if we cast our minds back to pre-COVID, and these figures are expressed as percentages. If you take 2019 as the starting point, and assume 2019 passenger levels at 100%, at that point we forecast going to 140% by 2027. So in the following 8 years, we were going to increase passenger levels by 40%. But then COVID happened, and passenger levels actually reduced to 39% of 2019 levels in 2020, and picking up slightly to 51% in 2021, 2022 to 73%, and according to current projections, the best estimate, the current projection is 94% worldwide passenger levels compared to 2019. Although I've been talking to some airports today who've actually exceeded 2019 levels this year. So it depends on the geography, the airport, the location, and the nature of traffic. It's fair to say leisure seems to be leading the way in terms of aviation traffic recovery, from my perspective. So where are we going to end up? Well, we're not going to meet according to projections, even the most optimistic projection is below the 2019 predicted passenger levels for 2027. However, we're looking at between 114 and 131% of 2019 levels to be recovered to by 2027, which is a huge when you consider where we were in the depths of 2020, 2021. So very good for our industry, and if we can do it with improved environmental products, then it might even be okay for the environment. Although that does beg some questions. But that's not the topic of today's. We might do that one of our webinars. What the aviation industry is doing for the environment. So moving on to the next slide, we have a summary of these are some slides selected from Tony's presentation looking at the origins of our standards. So it's very important to understand why the lighting system is designed as it is, and what the function of the visual aids that we provide is, and why they're so important. So if I could hand over to you, Tony, if you could just summarize these slides and give us that perspective as one who actually created the standards in the first place, who designed the system in the first place. Over to you, Tony.
Thank you. Not all my own work, a lot of other people contributed to this over the years to where we've got today, but I certainly enjoyed and hope made a useful contribution along the way to the fulfillment of these, first of all, defining the operational requirements and then fulfilling them by doing experimental work and demonstrations and feeding that through the visual aids panel. This afternoon a very quick summary of stuff that we looked at in much more detail earlier in the year. Why do we need lighting at airfields and airports? Well, very early on in aviation, of course, the problem of not being able to see anything at night was a very big hindrance to the development of flying. And the story that is told of Lindbergh flying the Atlantic solo and arriving in Paris and his arrival at night, and the field was illuminated by people parked around the side of the landing area, putting their car headlights on and illuminating the ground like that. Surely helpful, but not ideal, as then development work demonstrated. But it does highlight the fact how essential it is that the pilot has visual aids. First of all, at night, and then extending it to a much more difficult way in some ways to providing the adequate visual cues when the visibility is compromised by, for example, in particular, fog forming, where the distance that can be seen ahead of the aircraft is severely limited by meteorological conditions. So what we've got now, specified through Annex 14 and national standards, is a set of operational requirements and how to fix it, provide the necessary visual aids. First of all, then, if we look at this in a sort of organized way, aircraft making an approach, the pilot needs alignment in the lateral sense, left and right of the center line, and roll cues, because he needs to, or she needs to be lined up with the center line of the runway, and also to be, if you like, wings level. So they get, actually, the aircraft is actually following a trajectory that's actually going to go to the runway and along the runway, and not across the runway or largely offset. So alignment cues in the lateral sense, and then having got near the runway, then from the runway, further development of those cues from things like runway centerline lights, which as the visibility reduces particularly, are very important when in fact pilots are still required perhaps to roll out with only 2 or 3 lights in view at one time in the very low visibilities. A safe flare, a touchdown, a ground roll, and indeed a takeoff are materially benefited and enhancing safety by having runway centerline lights. And also on the runway, the touchdown lights, the pattern of lights in the area between the threshold and the area where the aircraft is should be landing. Adding textural cues. One of the things that became obvious as understanding developed over the years was you could make quite a good approach on approach lighting, but then if the runway, effectively, the lighting was only on the edges of the runway, at the latter stages of the approach, during the flare, the pilot needs good cues as to what apparently seems to be happening immediately where he's going to land. Those small cues where things slide slightly sideways or up or down, the texture gives you that, a sense of the small perturbations of the approach, which if you can't correct them, become large perturbations of the approach and can land in a missed approach or a bad landing. So textural cues filling in that black hole beyond the threshold for the flare and the landing. Now, once an aircraft's established on the approach in low visibility, those visual cues still need to be provided to the best one can in the circumstances. Obviously, you can get to the point where the fog is so thick that no light will be seeing anything like the visual range that you will see a light in good visibility. That we all understand, I think, from trying to drive around on the road at night in low visibility. But what we established, and particularly this became very apparent after in the UK after a very bad accident in 1969, where an aircraft on final approach, which had made quite a nice stable approach initially, actually at the late stage had a very excessive rate of descent on because of the visual cues not decreasing. They decreased, having had adequate cues at the decision point, and then because of the nature, not so much of the fog, but of the visual cues as then provided by ICAO, they didn't have enough vertical beam spread to ensure that the visual segment, the amount of lighting the pilot could see, didn't decrease once you've made the decision. And that's a dangerous thing. If a pilot makes a decision on what he sees or she sees, and then because of the lack of properly designed lighting, there's a decrease in what the pilot sees. That can happen very easily if the approach lighting is good, but the runway lighting is poor. And so maintenance plays a big role in that. You've got to maintain what the pilot has made a decision on, and hopefully it will increase as the pilot approaches the actual landing, but it should not ever decrease. And of course, from an airmanship point of view, any good pilot will know that don't make a decision to land above a fog top. If there's shallow fog, you can be very misled. You may see quite a lot of lighting in the early stages of the approach. And then as you enter the fog, what the distance you can see will be very much reduced. The RVR reporting is a good measure to stop you being misdirected by that. But generally, if we're talking about mature fogs, you're in the fog before you see any lighting, and then once you've seen it, you should see more and more of it as you make a descent. And that should be true whether you're exactly on the center line or displaced left or right or somewhat high or low on the ideal glide path. Those boundaries are shown in Annex 14, where you should expect the same service from your lighting, whether you're left, right, high, low. The design case for the intensity of all this lighting is the precision category 3 landing operations, and indeed takeoff operations as well. But the lighting designer should bear in mind that the lighting that's provided, if you like, because you operate category 3 operations, must also be adequate in beam spread for non-instrument approaches where the pilot may well be somewhat displaced from the center line in the early stages of the approach. Because this lighting has to be available for non-precision and circling operations as well. In the circling approach operations, there's a need for an omnidirectional lighting component on the runway edge, for example, so that the pilot can actually fly visually a circling approach. So there's very briefly, and there's a lot more detail, but we may need to move on. What I haven't mentioned up to now has been visual glide slope indication. It's a statement of fact, a good aviation practice. Pilots will be taught this in their training, or should be, that if you want a good landing, then fly a stable approach. You shouldn't be flying about all over the sky. You should settle down on the correct glide slope, aligned laterally, so that you make a stable approach, and so that a particular part is flying the aircraft. When he has to she has to make that flare decision and flare the aircraft is indeed traveling down the runway and hasn't got a velocity sideways or whatever. So a stable approach is important. And of course, this can be upset by wind conditions, particularly wind shears, that you need an aid to make sure you stay on the glide slope right the way down to the threshold. And the reason why we have to put a special visual aid in there is that you can't get any precise alignment cues in the vertical plane by looking at the ground. It's very approximate. I remember looking at data some time ago for general aviation, where, if you like, the approach was supposed to be a 3-degree approach. I actually made measurements, and you got anything between about 1.5 and 6 degrees, and pilots were convinced they were flying a 3-degree approach because there was no glide slope indicator there. So to be in the right place, doing a stable approach, you need a good glide path indicator. It's accurate and height rate information is crucial, particularly in some of those more difficult places where you are, in fact, by definition, by the operation you're doing, you're flying in safe airspace, but the clearance below you perhaps is quite minimal. There, I remember the approach into San Diego, just flying above the rooftops for quite a long time, just parallel on the side of a hill. There are other cases I read the other day where pilots said, well, the PAPI saved the disaster because I lost all sight. It was where there was a hill on the approach, and the aircraft got low, and the PAPI disappeared from sight. And so the pilot was alerted and corrected his rate of descent. And as I say, without this good approach guidance, your obstacle clearance criteria may be infringed.
Can I just
benefits of having a glide slope indicator like PAPI, which is accurate, which manually flown will do as well in terms of actually where the aircraft goes, as well as if the aircraft is coupled to the for a Category 1 ILS approach. It's very precise, and the touchdown scatter then is minimized, because if you've done a stable approach to the right place, the scatter on your touchdown is reduced. The data we gathered when we were doing the work showed that more than half the touchdown envelope, if you like, on the runway. We used that information in the visual aids panel when back in the 90s we were looking at something the American FAA were particularly keen on, was land hold short operations, where you had 2 runways, one of which crossed the other partway down that main runway, where they wanted to operate 2 runway streams at the same time. And as if you look at the operational requirements there, a PAPI is fundamental to that operation. You have to have a PAPI in the runway on the whole short runway to ensure you don't infringe the larger runway in the type of operation you're doing. So,
Tony,
yes.
Tony, I've got a couple of observations from this year. You know, we do a lot of PAPI testing. One is the practice I've discovered in a few airports, not just a few, but I would say a concerning few, whereby PAPIs are being adjusted from their prescribed setting angle according to directions directly from the pilots of test aircraft. And then those new angles are being adopted for clinometer checks thereafter. I'm rather concerned about that. What are your comments?
Yes, it's a bit disturbing to hear that. I mean, I've spoken to you many a time, and I've spoken in these webinars that flight checks are not precise checks. You cannot, if you like to do the sums and you like to understand the accuracy with which aircraft are flown, you cannot calibrate a precision aid where the setting angles have to be within a very small number of minutes of arc of the specified value. You can't do that by a pilot flying either descent profiles or flying level through the system with a stopwatch or whatever. Whatever way you try and do it, I challenge you, if you start doing back of the envelope things and putting in the likely errors, for example, there's always a delay between seeing something and pressing the button to say, I've seen it. So that produces now height, you assume, if you like, you're flying straight and level. I know from experience that even with a pilot flying manually, if you ask them to fly a particular height, the best they will offer you is plus or minus 10 feet. They'll say, I can just about achieve plus or minus 10 feet if you ask me to fly at 500 feet. They have to use their instruments and scanning. You do not get exactly 500 feet. You might well get 480 or 520 on a random sort of basis. So, you know, that you can see the errors that build up there. Does that sort of give you a sort of background?
Yes, just so yeah. But it's just something I would you know, if there are issues like that, I mean, you know, you need to address the underlying issue that's causing the problem, not adopt these because in our experience they're not accurate either, even when they do get them. So
I just say something. I think there's a good analogy, and that is what surveyors use instrumentation to measure angles and so on. Okay, theodolite.
Yeah.
Now that theodolite is made to a good standard. It is calibrated, and if you buy one of those, you do not expect to challenge or to query the accuracy of the measurements. No, the PAP is like that. It should be set up so it should be so designed that you wouldn't expect maintenance engineers to be doing anything to it as a projector in terms of setting angles. It should have setting devices, either a place for an inclinometer or a built-in inclinometer, which should be calibrated. And by the way, repeatedly calibrated, not something that was last calibrated 10 years ago. You know, if there's any concern about the theodolite, you don't expect the maintenance engineers to take it apart and try and correct it and send it back to the manufacturer to sort out. And that's what should be happening with the package.
Right. So, Tony, if we move on to signs now, if you give us your insights to those.
Yeah, well, the basic requirement there, any visual aid, there's 4 attributes it must have. It must, for aviation, for roads as well, for example, any visual aid has to be conspicuous. You have to be able to see it. The pilot has got other tasks to do. He's looking for the runway. He's looking for the on the approach. He sees that light, but then he's got onto the taxiway. He needs to see this signage, which is important. And I say it's important. I remember having this system, which has been we carefully developed it within the visualization panel. We did a lot of trials work both in simulation and real life to come up with what we've got now. The first thing is that the sign must be conspicuous. You shouldn't spend a long time doing a search to find it. And when you found it, it should be legible. It should be easy to read. And that, of course, immediately gives you specifications for the size of the sign and the size of the letters, and indeed the colors you use for contrast. All those things that make things legible, just as when you're reading a book, lighting levels and contrast of colors. There's a product I sometimes use in my kitchen where the instructions on how to use it is light blue on a slightly darker blue background. Very difficult to read. So it is intensity, it is color, it is size of letters. All of those things make it legible. And then the sign has got to be credible. You have to be, the sign must, the pilot is seeing the world around and seeing other taxiways and aircraft. It must be credible. You say, oh, well, I can believe this. Yeah, that makes sense. I look at my ground chart. Yes, I can see it. I believe it. I believe it. This sign is correct. And then comprehensible. What the sign's telling you, say at a junction, is easy to understand, to interpret, and then use. And so the signs are there to enhance safety by providing information that augments the situational awareness that pilots have from other places, like the verbal ATC instructions. And they will use what's on the sign as references. That, for example, the taxiway designation, they will pass that to a taxiing pilot. Use taxiway alpha to hold position on runway 2709, whatever, however they do it. And then the airport map has got all this information on it, the pilots have. So, but the signs are also, particularly I say safety, one important thing is the basic ring of red concept, which the visualize panel concerned as it was because aviation was concerned about runway incursions, not necessarily and not mainly in low visibility conditions, but runway incursions where taxiing aircraft and indeed ground vehicles go onto an active runway and cause a hazard and potential accident. So we discussed, and I have an idea, perhaps I first used the word ring of red, but it doesn't matter, that we'd actually draw a red ring round a runway, so that of course intersects every access to the runway, whether it be a taxiway, a crossing runway, or a roadway system, that there's a ring of red and there is visual cues at all those places, so that on the basis you do not pass a red instruction, you do not pass the ring of red without getting a clearance, either by the signal being changed to say you're safe to proceed, or a traffic light, or a verbal instruction, or possibly more than one of those from ATC. So there's this ring of red. You do not enter that area without getting responding to what the visual cue tells you you're about to encounter. So there we are, basic requirements of signs. Again, a lot more detail, but not today. We did it over the last 12 months. Except to say that just a quick look at how what we fed into the sign design. We said that signs should be viewable for 10 seconds. And you might say, well, in thick fog, if you're taxiing at a speed which you think is adequate for staying on the taxiway centre line, I probably can't see 10 seconds ahead. Well, the answer is that what the pilot will actually do in those circumstances, he will taxi at much lower speeds anyway. So although he can't see the same distance, he'll still effectively adjust his speed. So he's got 10 seconds to make up his mind. Typical taxiway speeds, and this is just typical, but on many major airports, out on the movement area, aircraft are regularly taxiing at 30 knots. In low visibility, that may well drop to below 10 knots. The viewing range, based on a taxi speed of 30 knots, should be by day and by night, should be 500 feet. That gives you time in that 10 seconds then. That's what the 500 feet is equivalent to 30 knots, 10 seconds. That gives you the time to, having seen the sign, read it, and then the mental process to say, oh yes, I know where I am, and I now know what I've got to do, so I'll take the appropriate action. Those decisions all take time, and so you need to have that in view long enough. I don't know about you, but I get very infuriated in another environment on roads where you get road signs that say some great event like the road's going to be closed or something. A sign is put up with a lot of text on it, and if you're driving your car at 50 miles an hour or 80 kilometers an hour, whichever you prefer, you just can't read the sign and the time available. It isn't big enough and for purpose. If you're walking, yeah, it's fine. But many of those signs that are certainly on our motor roads telling you that something's going to happen in the near future and the road's going to be closed just aren't big enough and viewable for far enough away to be useful. They're a waste of time, very largely. And so then you have to have a sign luminance. The brightness of the surface has to be sufficient to meet the viewing range requirements. Where you put them, there's a standardized procedure for that. That's all to be found in Annex 14 and then interpreted in many national standards. And the luminance, again, is standardized, found to be adequate, certainly for nighttime operation. However, it was limited to some extent by the practicality of what engineering in the 1980s and 90s could achieve in terms of sign luminance. That's always a constraint in developing visual aids is what's practicable, what the engineers can actually achieve. It's all very theoretically saying we want this, but if it isn't practicable, you have to try and find a solution which at least will be adequate for the task. But perhaps I can know if I can make it better in the future, I will. The font layout, in other words, what letters or other symbols are on there. It's important to have an agreed and standard, and they're all shown in Annex 40. But you'll see where you've got a sign at a complicated junction where you've got more than one entrance and exit. You will find in this system we developed that the taxiway you're on, which is a yellow letter on a black background, that's in the center of the display that you're presented with. So you sort of, in your mind, you orientate yourself. Oh yes, I'm on taxiway Alpha. Now to the left, I've got taxiway Bravo and Charlie, and to the right, I've got taxiway Alpha and Delta, where that letter is put depends on the degree to which you're having to make a turn. So the turns are nearest to the direction you are currently traveling in are closest to the letter that specifies the taxiway you are currently on. And so as you go, as the turn that you require is greater, then further out from it is. So it's logical to that layout. We did some very interesting human factors trials with that. Some folks said, well, it's much easier for sign manufacturers just to put the runway designator on the end, or the taxiway designator on the end rather than in the middle. We actually did trials where we showed if we use this layout, we gave the subjects a series of pictures of signs and said, now do a plan view of what the layout is. And they were given, I think, 10 different sign layouts. And they were given 10 seconds for each set. So in 100 seconds, they had to complete the task. So you got 10 seconds for each one, tying up with the 10 seconds viewing time. When we used this layout that we finalized, we had 100% correct answers, and often the task completed within the 100 seconds. With variations that were suggested, we often and generally got errors, and some of the test participants not finishing the task within time. So we were fairly confident that this was the best way of laying out all your signage. The font height, actually, for rule of thumb, if you like, the height of the sign should be 1/400th of the viewing range. That's to do with pilot visual perception and what they can resolve. So, you know, if you're viewing from 400 yards or 400 meters away, the letters have got to be 1 meter or one yard high. So it's a good. So 1 in 600 you can cope with, but 1 in 400 is comfortable. But you don't need to go bigger than that. And in terms of adding information, if you get a mandatory sign, it's red and white. These are the things you must obey. That these are signs that have to have information signs that enhance your knowledge of where you are. They're yellow and black. As I already said,
So Tony, I've got far too much lined up for today. What I propose to do now is, just because I know some of you we've developed a prize quiz for everyone to participate in. Okay, what was the busiest airport by number of passengers in 2022? We've got multiple choice there. So you select one of those airports on your device. 2 seconds, 1 second to go. Your time is up. And the answer was, of course, Dubai. Atlanta. And we've got 11 people got that right. So the look at the next question. Which airline was the first offer business class? Now, this was actually, there's a bit of contention here. We could have some disagreement with the answer, but I've Googled extensively. I've read all the articles, and my decision is final. So good luck to you all. Okay, your time is up. So the leaderboard now. Felicity doesn't count. Zeki there in effectively in first place. Well done. You do count, Felicity, by the way. It's just the quiz I'm talking about.
Thank you.
Right. So now we'll go on to question number 3. So the question number 3 for you here. Yes, Pan Am. Some younger people won't even remember that airline. So Pearson Airport lies in which city? Nice to say Pearson is a mum's customer. So 3 seconds. leaderboard. Right, so there's Felicity is in the lead, Zeki, and Ant-Man in number 3 place. And a majority of you got that one right. It was indeed Toronto. Next question. PAI is the national airline of where? Which is the PAI, the national airline for? So very quick, there's 4 more of you still to answer there. Time's up. The answer was, of course, Pakistan. And Bob leapfrogs into the lead. So well done, Bob. On to the next question. PEK is the international airport code for which airport? A tricky one, but obvious, but also obvious. So I wish you luck with that question. PEK, which airport? Which airport? Charlemagne Sandal. Well, so the answer, of course, was Beijing, formerly known as Peking. So congratulations to those who got that right. Next question. So the busiest airport in Africa is in what city? Is it in Nairobi? Is it in Lagos? Is it in Cairo? Is it in Johannesburg? Which is it? Busiest airport in Africa. Right. Well, the answer is Johannesburg. So let's see what that does to the leaderboard. Matt Flynn coming up there. So it's it's good to see all these names popping up on the leaderboard. So come on, we've got down to another three or four questions. Let's go on to the next round. So what is the airport code for Da Vinci Airport in Rome? What is the airport code for Da Vinci Code in Rome? Bit of a tricky question, that, but if you know it, you'll know it. Let's see how you get on. Right. The answer is FCO, which I believe is Fiumicino. And John. John. Now, I was looking to see John's name on there before. John won it last year, so please don't let John win, guys. It's got up, especially. I don't know what time it is. John is in New Zealand, so he's got a bit between his teeth. He's determined to win this. So, come on. I'm nothing against you, John, but somebody else is going to win this year. Next question. When was ICAO Annex 14 first published? So, when was ICAO Annex 14 first published? You're reaching for your copies there. Right, and the answer is, I believe, 1951. Kent Krause, so it's 1951. So, yeah, so it's a lot of changes on the leaderboard. Next question. What does MARM stand for? This is often when people ask me this question. What does it stand for? Magnificent Airfield Lighting Management System, Marvelous Airport Light Measurement System, Mobile Airport Light Monitoring System, or Magical Airport LED Measurement Software. If that's the case, the leaderboard. Kent Krause there, John hot on his or her tail, and it was in fact mobile airfield light monitoring system. Right, not long left here. Which one of these, this is the last question, which one of these is not one of the 4 C's? Very tricky question there. Which one of these is not one of the 4 C's? Configuration, color, coverage, or Christmas? Well, Kent Krause has won it. I'm pleased to say that 16 of you got that right. And so next question here. So the answer is the leaderboard, I think starting in 3rd place, which add up the so 53% accuracy of scores. 3rd place was Bob. 2nd place was John, and Kent Krause was in 1st place. Well, so so if you make yourself known to me, Kent Krause, I will happily award you, make your charity of your choice known to me. Then we will happily donate £100 to your charity of your choice. So thank you very much. I hope you all enjoyed that. I was disappointed to see not one of the panelists on top of the leaderboard. How did you do, Keith? Oh, there we are.
Mute, Keith.
Here we are. Here's the lead. Here's the top of the leaderboard. So so you can see there. And so well done everybody. I hope you enjoyed that. A little bit of fun, light entertainment to conclude our webinar for today. We will publish the full presentation so you can see what we didn't get time for. But I think that was I thought that was it's a traditional way to finish off our webinars. And if I can just go back to my Zoom screen. I've lost the stop share. Right, so here we have the panel. So there you are, guys. How did you get on with that? Seward, how did you get on?
Oh, well, it was fun. I did not participate. I had something else going on, but it was very good. It was very, very interesting questions.
Yeah. And Tony?
1 or 2. Yeah, got most of 2 or 3. I think the AirPod identifiers I struggle with a bit.
Mm-hmm.
Yeah, things like that. But yeah, a lot of it I got right. But, yeah.
And Keith, I hope you got the 4 C's right. Keith, you're muted. Keith is, unfortunately we can't hear Keith, so we'll move on to Carl until Keith unmutes. Carl, how did you get on?
I agree with Tony. The airport identifiers threw me a curve, but otherwise they're all good.
Right. Yeah. So sorry, I didn't mean to. I mean, you have to have questions for everybody and every geography, because obviously if you're it's one of the challenges.
Christmas would be a good 5th C though.
Yeah. Well, it is this week anyway. And Keith, you were saying we couldn't hear you.
Yeah, sorry, I've unmuted now, but I thought to myself when I saw, you did send me those questions in advance, Robert, when we were discussing. Yeah. And the 4 C's, I did get it right because I did Google it. And so when I Googled it, it said critical thinking, creativity, collaboration, and communication. And I thought, well, I think I put the wrong industry in,
I think so.
Yeah. Good. Well, look, I mean, it's just a bit of light entertainment there, and just to try and wrap up the year. But we've got to, you know, it's another year passes by here, and we've got some big challenges facing the industry as we recover back to pre-COVID levels with traffic, and by, you know, with ever increasing amounts of technology on the airfield, we've sadly lost a lot of experience. Airports have lost a lot of experienced people throughout the COVID process period, and so you know, it's not going to, life isn't getting any easier, and so we look forward to 2024. We've got a presentation, we've got an interesting topic, something we haven't covered before. That's the measurement of insulation resistance, as known by the product Megaring. Seward, could you just give us where Seward came up with this one? What made you think of this?
Well, I think about it a lot, and we've talked about it a lot in our training sessions over here in the States. But, you know, we have this perception that this series circuit that's out there is just a flawless device. Current follows it around, doesn't go anywhere, doesn't leak, nothing happens. And that's far from the truth. And what we do to troubleshoot series circuits to find out why we don't have 6.6 amps or 5.5 amps in one particular area is we measure it to find out where the leakages are, where the flaws are in the design, or not necessarily in the design and the maintenance of the circuits. And so it'll be basic. We'll have some basic discussion about the characteristics of the series circuit, and then we'll just talk about what does measuring contain, how do we do it, and it's simpler than we think it is. So if we just try to have an orderly presentation of what it's all about, and I'm looking forward to it. I'll send it to you, so you're going to preview it.
Good. Well, no, we're looking forward to that. It's good. Now, you will all have an opportunity to fill out a questionnaire following this webinar. So please put in the topics that you're looking for 2024. You know, this is for your benefit, this webinar. So let us cover the topics. Let's give you the content that most interests you, that's most helpful to you. So we'll just understand that Kent is based in the USA. I look forward to give me your contact details, and then we'll get back to you after this webinar.
Kent has sent a message, by the way, on the Q&A.
Okay, great. Look, I mean, it's been a lot of fun this year. I have to thank everyone that's participated in it from a panelist point of view, and also from all the participants actually joining us. With that, obviously, this is why we do the webinar, and it's amazing the geographic split. You know how we cover the world with this webinar. So it's very encouraging to see the motivation we have. It's an environment, it's an industry where people are full of passion for what we do, and that is very energizing to work in that environment. It's a very exciting, dynamic, but also very important. It's critical, safety critical environment. So thank you all for your participation. I'd just like to go around the panel to say give the viewers your Christmas wishes. Tony?
Yeah, as you say, it's an exciting industry to be in. It is from the research point of view, because I've had a very fulfilling life doing it. And it's great still to be able to be part of this, and thank you for that, Robert. And I just wish everybody the season's greetings, and hope perhaps everybody's got some sort of holiday. Hope you can have a refreshing time. Look forward to seeing you in the new year.
Thank you, Tony. And Carl?
Well, Merry Christmas, everybody, and have a Happy New Year.
Oh.
Ho, ho, ho. Yeah. And Seward?
Merry Christmas to everybody. I hope it's a very meaningful, happy time with a lot of good memories, and be thankful for what we have to celebrate.
Right. And Damon?
Have a great new year. Have a happy holidays and see you again in the new year. Yeah, it's been a wonderful year.
And Felicity, you there somewhere?
I am. Yep. Merry Christmas, everyone. All the best for 2024.
And as usual, we'll always give Keith the last word. So, Keith, over to you.
Yeah, hi everyone. By the way, thank you very much for your condolences that I've received. But 2024 going to be good. It will always be good. God gave us this day to do with as we want, and one of the things I've always remembered. But what we do with this day is important, because when tomorrow comes, today's gone forever.
Right. Thank you. Very
And
good.
so have a great Christmas, and let's look forward to a very happy and prosperous 2024.
Okay, and we're obviously all thinking of you at this difficult time.
Thank you,
Keith.
Keith.
So thank you for joining us today. So, right, well, look, thank you everybody. Thank you everybody that's participated as on the panel. Thank you, Damon and Felicity, for putting it all together, and thank you all the participants, for without which this there would be no point. So, have a great Christmas, or however you want to celebrate, and we will look forward to seeing you on the 30th of January, where we'll be talking about measurement of insulation resistance, otherwise known as meggering. So thank you, guys. See you soon. Merry Christmas. Bye.
Merry Christmas.
Bye.
Bye.
Cheers. God bless.
Bye.
God bless.